Yeah. Threshold voltage and threshold voltage adjustment. You people know what is threshold voltage? VT. Okay. Threshold voltage, how do you define it as threshold voltage? The minimum voltage required to turn on the device. Very simple words. So, threshold voltage adjustment means what? I can change or I can adjust the threshold voltage of any MOSFET. That is threshold voltage adjustment. Okay. So how to do that? How to do that? Say if I have a MOSFET, in this MOSFET, if I keep the SiO2 layer, here there will be a SiO2 layer, oxide layer. Okay. So threshold voltage can be adjusted when I change the thickness of oxide layer. How it changes? ಹೆಂಗಾಗ್ತದ? ಭಾಳ ಸಿಂಪಲ್ ಅದ ನೋಡ್ರಿ. SiO2 layer it is acting like insulator or dielectric. Okay, ಇದರ ಮೇಲ್ಗಡೆ ಏನಿರ್ತದ? Metal ಇರ್ತದ. And we call that terminal as gate. This is metal. And this is oxide layer. So how it works? How the MOSFET works? When I apply some voltage, VGS, okay, there will be a field generated. Correct? Now, this metal and this semiconductor, okay, the difference or the gap between these two, if it is very, very less, a strong field will be developed. If you increase this width or the difference between metal and semiconductor, or indirectly what I am saying is, if you increase this width of or thickness of SiO2 layer, okay, then the field will be becoming weaker. And that field itself is actually responsible for channel formation, because it attracts the electrons. Say if this is N, this is N, this is P. For channel formation, all the electrons should be attracted. ಹೌದಾ? ಎಲ್ಲ electrons attract ಆಗಬೇಕು. So one case, the thickness of the SiO2 is very thin. At that time, electric field is very strong. And the other case, thickness of oxide layer is very large. So electric field, here it is weak. This makes the difference in channel formation or turning on the device. Channel formation and current flowing idella enu turning on the device. So thickness of the oxide layer by change, okay, there will be slight change in the threshold voltage. That is how we adjust the threshold voltage. One more way of adjusting the threshold voltage is you change the doping concentration of P-type material. Doping ಏನು ಮಾಡಿರ್ತೀರಿ, dopants add ಮಾಡಿರ್ತೀರಿ. Change the number of dopants. Doping concentration change ಮಾಡಿಬಿಟ್ರೆ electron and hole movements ಏನಾಗ್ತದಲ್ಲ, ಮ್ಯೂಚುವಲಿ ಎಲೆಕ್ಟ್ರಾನ್ ಎಲ್ಲ attract ಆಗೋದು, holes repel ಆಗೋದು. So if the number of charge carriers change, the time required to move from one point to other point changes. So that will also impact on the threshold voltage. So if it is 0.7 volts, imagine this is silicon MOSFET. Okay, its threshold voltage is 0.7. You want to adjust it to 0.68 or 0.71. Slight change you want to do. Then what you have to do during the fabrication process, during the manufacturing process, you change the thickness or change the doping concentration. You can adjust your threshold voltage. This is how we adjust the threshold voltage. Okay, understood? Next is design equations of the MOSFET. This is the most important part of your module 2. 100% it will be asked. Okay. In exam, final exam, this question is repeatedly asked. So, to study this design equations of MOSFET, first we have to understand that the MOSFET works in three regions of operation. This graph we have seen. Here the current is getting saturated. White is getting saturated. What is this? Pinch off voltage. So after pinch off, current is saturated. What is pinch off? If you look into the structure, your MOSFET channel width is almost very thin, almost nil. Okay, that is pinch off. So here where the current is getting saturated, okay, that is called as saturation region of operation. Where current is constant, current change agatiಲ್ಲ. Okay. So this region of operation is called as saturation region, or the MOSFET is in saturation region here. Current is saturated. This region, is called as linear region of operation. Why it is called as linear region of operation? Because the current is increasing linearly. And this shaded part is cutoff region. This is cutoff region, this is linear region, this is saturation region. Cutoff region means MOSFET is off. MOSFET is off, it is not on. Okay. Linear region of operation means MOSFET is on, current is increasing linearly. Saturation region of operation means what? MOSFET is on, current is not increasing, it is saturation. दोनों अर्थ एकदम कट ऑफ ಅಂದ್ರೆ कट ऑफ रीजन ಅಂದ್ರೆ MOSFET is off, no current. Linear region ಅಂದ್ರೆ MOSFET is on. How is the current? Increasing linearly. Saturation region? MOSFET is on. Current is saturated. Neither increasing nor decreasing. Saturated. These are the three regions of operation. And in this topic, design equations or equations of the MOSFET, okay, in this topic we will come to know the three equations of the MOSFET in the three regions of operation. Even more regions daga MOSFET the mathematical equation kaliತೀವಿ. Okay. So So for that, let us understand the geometry or the diagram of MOSFET. So this is the diagram of MOSFET where diagram you know actually what is what and all you know, but there are few terms which you people don't know. Say this is CG. CG is nothing but capacitance. Z and the capacitance. Okay. So it is actually gate capacitance. CG, gate capacitance. And the voltage between gate and the source is known as VGS. The voltage between gate and drain is nothing but VGD. ಇದು ಬರ್ಕೊಳ್ಳೋದು ಬೇಡ, ನಾನು ನಿಮ್ಗೆ ಇದು ನೋಟ್ಸ್ ಕಳಿಸ್ತೀನಿ, ಅರ್ಥ ಮಾಡ್ಕೊರಿ. ನೀವು ಬರೀತಿರ್ತೀರಿ ಯಾವಾಗ ಇದರ ಅಟೆನ್ಷನ್ ಇದೆ ಅಷ್ಟೊಂದಿಲ್ಲ, ಇಲ್ಲಿರ್ತೈತಿ ಅಟೆನ್ಷನ್. ಇದು ಆಸ್ ಇಟ್ ಈಸ್ ನಾನು ನೋಟ್ಸ್ ನಿಮ್ಗೆ ಕಳಿಸ್ತೀನಿ, ಫಸ್ಟ್ ಅರ್ಥ ಮಾಡ್ಕೊರಿ. ಅಥವಾ ನಿಮ್ಗೆ ಬರ್ಕೊಳ್ಳೇಬೇಕಂದ್ರೆ ಟೈಮ್ ಕೊಡ್ತೀನಿ. ಸೊ ಇದ್ರೊಳಗೆ CG means it is gate capacitance. Gate capacitance ಅಂದ್ರೆ ಏನು actually? See, this is what metal. So this is like one plate of the capacitor which conducts. Metal conduct ಮಾಡ್ತೈತಿ. ನನಗೆ ಏನೈತಿ insulator or dielectric. ಕೆಳಗಿನ ಏನೈತಿ semiconductor that also conducts. So this part is acting like capacitor. This is gate. Malin gate, that is oxide, which is insulator. Kelvin semiconductor. So this structure is acting like capacitor. Therefore, I am calling it as gate capacitance. Okay. Here I am giving the voltage. So this voltage between gate and source is VGS. Voltage between gate and drain is VGD. VG minus VD, VG minus VS. Clear? And one more diagram I have where we define few more terms. This is actual diagram. What is this? TOX. OX andre oxide. T andre thickness. Thickness of the oxide. Okay. What is this? L. Length of the MOSFET. Actually, in the previous class I explained difference between or the distance between drain and source is length of the MOSFET. So this is drain, this is source. Difference between these two is length of the MOSFET. Okay. And what is this? This is width of the MOSFET. 3D diagram it is. Fine. Next, what we have is a few basic equations you might be knowing that I have written here. Q is equals to C into V. Q is equals to C into V. I think you might have come across it in PUC or charge on the plate of the capacitor is given by charge on the plate of the capacitor is given by Q is equals to C into V. Okay. So here charge in the channel is given by charge on one plate of the capacitor is given by what? Q is equals to C into V. This is of the capacitor. Okay. So this is ಮೇಲಿಂದ ಗೇಟ್, ಕೆಳಗಿಂದೇನು ಸೆಮಿಕಂಡಕ್ಟರ್. ಸೆಮಿಕಂಡಕ್ಟರ್ ಏನು ಹಾಕಿದೈತಿ ಚಾನಲ್ ಹಾಕಿದೈತಿ ಚಾನಲ್ n channel. So we are defining the charge of the plate of the capacitor is q is equal to c into v, where q is q channel, the number of charge carriers in the channel. Channel ಒಳಗೆ ಎಷ್ಟು charge carriers ಅದಾವ, ಎಷ್ಟು electrons ಅದಾವ, that is given by c ಅಂದ್ರೆ ಏನಲ್ಲಿ gate capacitance Cg into V. V means it is VGC minus VT. VGC ಅಂದ್ರೆ ಏನು? Minimum voltage for inversion. ಅಂದ್ರೆ minimum voltage for inversion ಅಂದ್ರೆ ನೀವು ಎಷ್ಟು ವೋಲ್ಟೇಜ್ ಕೊಟ್ಟ ಮೇಲೆ ಚಾನಲ್ ಫಾರ್ಮ್ ಆಗ್ತೈತಲ್ಲ, that is inversion. ಎಲ್ಲ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಮೇಲೆ ಬರ್ತಾವು, that is called inversion. ಎಷ್ಟು ವೋಲ್ಟೇಜ್ ಈಗ ಇನ್ವರ್ಟ್ ಆಗ್ತೈತಲ್ಲ, that is VGC, okay, and VT is actually what? Threshold voltage of the device. So charge carriers present in the channel is given by C and the gate capacitance, V and the what voltage is present there. The voltage which I have applied minus threshold voltage is present there. Okay. So you name this equation as equation number 1. Why we actually name it? Because we want to use it later. Okay, ಇದನ್ನ ನಾವು ಯೂಸ್ ಮಾಡ್ಕೋತೀವಿ ಮುಂದೆ ಡಿರೈವ್ ಮಾಡಲಿಕ್ಕೆ. So I am going through one derivation. Okay, first equation. Next Cg. Cg is what? This is permittivity. ಇದೆಲ್ಲ ಫಿಸಿಕ್ಸ್ ಅಥವಾ ನಿಮ್ಮ PUC ಒಳಗೆ ನೀವು ಕಲ್ತಿರ್ತೀರಿ. is epsilon of by T-ox into W into L. What is W or what is L? Width of the MOSFET, length of the MOSFET. This is permittivity. This is thickness of the oxide. Or this can be defined as COX. This can be defined as I like only. T epsilon naught by T-ox is COX. Okay. Next, let this equation be second equation, because this also I will use it later. ಅದಕ್ಕೆ naming ಮಾಡ್ತಾರೆ. Okay. Next, every charge carrier is accelerated ಅಂದ್ರೆ moving to the velocity which is directly proportional to the electric field between drain and source. So what they are telling, every charge carrier or every electron which is moving, okay, that is directly proportional to the electric field. ನೀವು ಎಷ್ಟು ಜಾಸ್ತಿ electric field ಫಾರ್ಮ್ ಆಗಿರ್ತದ ಅಷ್ಟೇ ಫಾಸ್ಟ್ ಮೂವ್ ಆಗ್ತದೆ. So V velocity is directly proportional to electric field. Velocity of the charge carrier is directly proportional to the electric field. Electric field kadme idre velocity of the charge carrier or velocity of the electron you take, it will be less. Okay. Or if I equate that equation, a constant comes into picture, that is called as mobility of the electron. So mu is equals to V by E. Okay. Velocity is directly proportional to electric field, but if I equate it, a constant comes into picture, that is called as mobility of the electron or mobility of the charge carrier in general. E is the electric field. Okay. And E, actually E, what is that E? How it is formed? Electric field hang form agada andre electric field is VDS divided by L. Electric field is VDS divided by L. L ಅಂದ್ರೆ ಏನು? Length of the MOS. L ಜಾಸ್ತಿ ಆತಂದ್ರೆ E ಏನಾಗ್ತದೆ? ಕಡಿಮೆ ಆಗ್ತದೆ. ನೀವು ವಿಚಾರ ಮಾಡಿ, ಇಲ್ಲಿ ಭಾಳ ಭಾಳ ಲೆಂತ್ ಭಾಳ ಜಾಸ್ತಿ ಮಾಡ್ಕೋರಿ ಆ ವೋಲ್ಟೇಜ್ ಇಫೆಕ್ಟ್ ಕಡಿಮೆ ಆಗಿರ್ತದೆ. ಕಡಿಮೆ ಏರಿಯಾದಾಗ ಜಾಸ್ತಿ ಇರ್ತದೆ ಇಫೆಕ್ಟ್. ಓಕೆ, ಸೊ E is electric field which is given by voltage divided by the length. Voltage divided by the length. Voltage applied divided by the length of the MOS. Next is ಇದೆಲ್ಲ ನೇಮಿಂಗ್ ಮಾಡ್ಕೊಂಡು ಹೊಂಟಿವಿ ನಾವು. This is equation 5. This is equation 4. Okay. Next time is equals to distance by speed. ಇದಂತೂ ನಮಗೆ ಗೊತ್ತದ. Time is equals to distance by speed. Okay. The time required by the electron to travel from source to drain, just length ಆಯ್ತು. Source to drain length ಎಷ್ಟು? Source ಮತ್ತೆ drain ನಡುವೆ ಏನೈತಿ? L. So ಆ L distance travel ಮಾಡಾಕ T time ತಗೋಬೇಕು. Time required is T for the electron to travel between drain and source. Move ಆಗ್ತಿರ್ತದಲ್ಲ. Okay, that is length. Distance ಎಷ್ಟು ಕವರ್ ಆಗ್ತದ? L. Speed, velocity of the electron v ತಗೊಂಡಿವಿ ನಾವು. Okay, so time is distance by speed. Distance is L. ಎಷ್ಟು ಮೂವ್ ಆಗಬೇಕು? Drain to source move ಆಗಬೇಕು. How fast it should move? It should move with velocity v. So this is T is equals to L by v. This also I will use it further. So ಏನೇನು ನೋಡಿದ್ರಿ ಇಲ್ಲಿ ಮಟ್ಟ ನೋಡ್ರಿ. First Q. Q is equals to C into V. C ಅಂದ್ರೆ ಏನು? CG. V ಅಂದ್ರೆ ಏನು? Voltage applied at that point. So it is VGC minus VT. Okay. Next ಏನು ನೋಡಿದ್ವಿ? CG ಅಂದ್ರೆ ಏನು ನೋಡಿದ್ವಿ? CG means it is Cox into WL. Cox into WL. Okay. Next, velocity of the charge carrier is directly proportional to E, or V is equals to mu into E. Okay. Then E ಅಂದ್ರೆ ಏನು ನೋಡಿದ್ವಿ? E ಅಂದ್ರೆ voltage divided by length. ಎಷ್ಟು ವೋಲ್ಟೇಜ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರಿ, ಎಷ್ಟು ಲೆಂತ್ ಐತಿ, ಅದರ ಮೇಲೆ E ಡಿಫೈನ್ ಆಗ್ತದೆ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಏನು ನೋಡಿದ್ವಿ? ಟೈಮ್. ಟೈಮ್ ರಿಕ್ವೈರ್ಡ್ by the charge carrier or electron to travel L, distance L, through velocity v is T is equal to L by v. Okay. Next is the main equation. ಈ equation ದಾಗ ಎಲ್ಲ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿಬಿಡೋದು. 1 ರಿಂದ 6 ಏನೇನು ಲಿಸ್ಟ್ ಮಾಡಿವಿ ಎಲ್ಲ ಇದ್ರಾಗೆ ಹಾಕ್ತೀವಿ. What is this? Current definition. What is current definition? ಇದು wire ಅಂತ ತಿಳ್ಕೊರಿ. If this is a wire, what is current? How do we define the current? Number of charge carriers traveling per unit time. Number of charge carriers traveling through this wire per unit time. ಹೌದಾ? I is equals to charge carriers per unit time. Number of charge carriers present in the channel. ಯಾಕಂದ್ರೆ ಚಾನಲ್ ಥ್ರೂ ಕರೆಂಟ್ ಹೋಗ್ಲಿಕ್ಕತ್ತದ. ಹೌದಾ? ನಿಧಿ ಬಂದ್ರೆ ಹೇಳ್ಬಿಡಿರಿ, ಹೋಗ್ಬೇಡ್ರಿ. Current is equals to number of charge carriers in the channel divided by time, per unit time. Okay. But T ಅಂದ್ರೆ ಏನು ಡಿಫೈನ್ ಮಾಡಿದ್ವಿ ನಾವು? L by V. So L by V substitute ಮಾಡಿದೆ. I is equals to QCH, okay, divided by L by V. L by V. Okay. Next, ಬೇರೆ equations ಎಲ್ಲ ಹಾಕಿದ್ದಾರೆ. QCH ಅಂದ್ರೆ ಏನು? ಇಲ್ಲಿ ನೋಡ್ರಿ, QCH ಅಂದ್ರೆ ಏನು? Yes. So ಅದನ್ನ ಹಾಕಿರಿ. I is equals to CG into minus Vt, okay, divided by L by V. Fine. ಮತ್ತ ಇದ್ರಾಗ ಮತ್ತೆ ಏನ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಬೋದು? CG ನು ಐತ್ ನೋಡ್ರಿ ನಮ್ದು. what is CG actually? epsilon of by T of into W into L ಅಥವಾ C of into W into L. Okay, so epsilon of into T of into W into L, this is what? CG. Correct? It's there it is, it's CG it is. This is kept as it is, this is kept as it is, okay. L is kept as it is. What is V? What is V? What is V? V is equals to n per series. Speed is equals to distance by time. Sorry. Speed is equals to distance by mu into E is equals to n. ಏನೇ ನಾವು ಲಿಸ್ಟ್ ಮಾಡಿವಿ ಎಲ್ಲ ಹಾಕ್ಲಿಕ್ಕೆ ಒನ್ ಬೈ ಒನ್ ಎಲ್ಲ ಇದರಾಗೆ ಹಾಕ್ಲಿಕ್ಕೆ. ಸೊ ನಿಮ್ಗೆ ಎಲ್ಲಿ ಕ್ಯಾನ್ಸಲ್ ಆಗ್ತದೆ? ಹೌದು, ಬಟ್ ಇಲ್ಲಿ ನಮ್ಗೆ ವಿಜಿಸಿ ಅಂದ್ರೆ ಏನ್ ಗೊತ್ತಾಗ್ಬೇಕು. ಐ ಡೋಂಟ್ ನೋ ವಾಟ್ ಇಸ್ ವಿಜಿಸಿ. ಓಕೆ, ಸೊ ಇಲ್ಲಿ ಮಟ್ಟ ಅಂತ ತಿಳಿತು. ಇದು ಅರ್ಥ ಆಯ್ತಲ್ಲ ಎಲ್ಲರಿಗೂ? ಇಲ್ಲಿ ಬರ್ದಿದೆ ನೋಡ್ರಿ ಏನ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಅಂತ. ವಿಜಿಸಿ ಅಂದ್ರೆ ಏನು? ಇದು ವಿಜಿಸಿ ಅಂದ್ರೆ ಏನು ಇದು ಯಾರಿಗೂ ಗೊತ್ತಿಲ್ಲ. ಇದು ವಿಜಿಸಿ ಅಂದ್ರೆ ಏನು ಯಾವುದು ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ನಾಗೂ ಇಲ್ಲ. ಓಕೆ, ಡೈರೆಕ್ಟ್ ಆನ್ಸರ್ ಬರೀತಾರೆ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಆಗ. ವಿಜಿಸಿ ಕಂಡುಹಿಡಿಯಲಿಕ್ಕೆ ವಾಟ್ ವಿ ಆರ್ ಡೂಯಿಂಗ್, we are understanding the structure of capacitor. So VGC andre okay, VGC means it is VGS plus VGD divided by 2. ಈ ಸ್ಟ್ರಕ್ಚರ್ ನೋಡ್ರಿ, ಈ ಸ್ಟ್ರಕ್ಚರ್ ನೋಡ್ರಿ. This is gate, this is gate, this middle one is oxide and this is semiconductor, so it is acting like capacitor. Here I am applying gate voltage VG. Okay, here I have source, left hand side I have source, right hand side I have drain. Remember the MOSFET structure. So source drain, so difference of voltage between this point and this point, okay, it is VGS. This difference is VGS, this difference is VGD, this difference is VGD. Okay, and I am applying a VDS also at the drain. Okay, so VGC is actually VGS plus VGD divided by 2. VGC ಅಂದ್ರೆ ಏನು ಡಿಫೈನ್ ಮಾಡ್ಕೊಂಡಿದ್ವಿ ನಾವು? ವೋಲ್ಟೇಜ್ ಮೇಲೆ ನೋಡ್ರಿ, ವೋಲ್ಟೇಜ್ ಫಾರ್ ಇನ್ವರ್ಷನ್ ಅದ. What is this? Minimum voltage for inversion. ಅಂದ್ರೆ ನಾ ಎಷ್ಟು ವೋಲ್ಟೇಜ್ ಅಪ್ಲೈ ಮಾಡಿಲ್ಲ that itself is VDC. for inversion. So for that, defining VGC, what I am doing, I am considering the voltage applied. Voltage applied is VG, but that VG can be considered as VGS plus VGD divided by 2. Split agada. Ikkade VGS, ikkade VGD. VGS plus VGD divided by 2. That is VGC. Okay, that itself is written here. Fine. Now you split it. Now you split this. VGS plus VGD by 2, we know. VGS, keep it as it is. Okay. VGD, you split it. VG minus VD whole divided by 2. I am just splitting this VGD. Okay. And actually, what is VG? VG and gate voltage. If I draw MOSFET, okay, this is oxide and this is metal, VG and potential, that is given with respect to what? VG and potential, that is given with respect to what? Source is negative terminal connected. So VG means it is VGS. VG ಅಂದ್ರೆ VGS ಯಾಕಂದ್ರೆ ಓಕೆ VG ಅಂದ್ರೆ VGS ಅಂದ್ರೆ ಏನು if I ask you VGS ಅಂದ್ರೆ you will tell VG minus VS. What is VS? Source voltage. Yes, it is. ಇಲ್ಲಿ VDS ಕೊಟ್ಟಿರ್ತೀವಿ ನಾವು ಹೌದಾ ಈ ನೆಗೆಟಿವ್ ಹೋಗಿ ಇಲ್ಲಿ ಹೋಗಿ ಕೂಡ್ತದೆ ಇಲ್ಲಿ. So what is this source voltage? VGS is actually STP. It is common terminal ಇರ್ತದೆ. ಇದರ ನೆಗೆಟಿವ್ ಇಲ್ಲೇ ಬಂತು, ಇದರ ನೆಗೆಟಿವ್ ಇಲ್ಲೇ ಬಂತು. ಬ್ರೆಡ್ ಬೋರ್ಡ್ ಆಗ ಎಲ್ಲ ನೆಗೆಟಿವ್ ಹಚ್ಚಿರ್ತೀನಿ ಇಲ್ಲ. ಯಾವ ಪಾಯಿಂಟ್ ಅದ? ಗ್ರೌಂಡ್ ಪಾಯಿಂಟ್ is voltage ಎಷ್ಟು? 0. So VGS means VG minus VS. So VGS is equal to VG minus 0. Therefore VGS equals to VG. ಅದನ್ನೇ ಈ ಸರ್ಕ್ಯೂಟ್ ಮಾಡಲಾಗ್ತದೆ. VG minus VD ಐತಿ. VG means it is VGS only. Okay. So just ಇದನ್ನ ಸಾಲ್ವ್ ಮಾಡ್ರಿ. VGS plus VG minus VD divided by 2 ಐತಿ. So VGS by 2 plus VG ಅಂದ್ರೆ VGS by 2 minus VD ಅಂದ್ರೆ ಏನು? VDS. ಇದೇ ಕಾನ್ಸೆಪ್ಟ್. VDS ಮಾಡ್ರಿ. VDS is equal to VD minus VS. VS ಅಂದ್ರೆ 0 ಐತಿ. So VD equals to VDS. Therefore VD ಅಂದ್ರೆ VDS. ನೀವು ಬರ್ದಿದೆ ಇದು ಮಾಡ್ರಿ ಇದೆಲ್ಲ. ತಿಳಿಲಿ ಅಂತ ಬರ್ದೇನಿ. ಇದೆಲ್ಲ ಏನು ಕೊಟ್ಟಿಲ್ಲ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ದಾಗ. ಇದೆಲ್ಲ ಏನು ಕೊಟ್ಟಿಲ್ಲ. ಡೈರೆಕ್ಟ್ ಆನ್ಸರ್ ಬರ್ತಾವ. ಓಕೆ. ಸೊ VGS by 2 plus VGS by 2 minus VDS by 2. VGS by 2 plus VGS by 2 ಅಂದ್ರೆ ಅರ್ಧ ಪ್ಲಸ್ ಅರ್ಧ ಅಂದ್ರೆ 1. So it is 1 into VGS minus VDS by 2. VGC ಅಂದ್ರೆ actually VGS minus VDS by 2. This is our VGC. Text book ದಾಗ ಡೈರೆಕ್ಟ್ ಆನ್ಸರ್ ಬರ್ತಾರ. ಓಕೆ. ನಿಮ್ಗೆ ತಿಳಿಲಿ ಅಂತ ನಾನು ಇಷ್ಟೆಲ್ಲ ಸಾಲ್ವ್ ಮಾಡೀನಿ. ಫೈನ್. VGC is VGS minus VDS by 2. ಈಗ ಇದನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. ಎಲ್ಲಿ ನಿಂತಿದ್ವಿ ನಾವು? ನಾನು ನೋಡ್ರಿ ಇಲ್ಲಿ ನಿಂತೀವಿ. ಈ ಈಕ್ವೇಷನ್ ಒಳಗೆ VGC I have to substitute. So what I substitute? VGC equals to VGS minus VDS by 2. VGS minus VDS by 2. ಇದು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. So 9 will put it in that equation. ಏನು ನೋಡಿ? VGC ಇತ್ತಲ್ಲ ಇಲ್ಲಿ. VGS minus VDS by 2. Actually ಏನಿತ್ತು? VGC minus VT ಇತ್ತಲ್ಲ ಈಕ್ವೇಷನ್ ದಾಗ. So VGC ಬದಲಿ VGS minus VDS by 2 ಬರ್ತೀನಿ. Minus VT as it is ಐತಿ. If you write this one this side or this one this side, ಒಂದೇ ಅದು. 10 minus 2 minus 2 ಅಥವಾ 10 minus 2 minus 3 ಅಥವಾ 10 minus 3 minus 2 ಎರಡು ಒಂದೇ. Okay, so VGC ಅಂದ್ರೆ ಇದು VGS minus VDS by 2 minus VD ಮೊದಲೇ ಇತ್ತಲ್ಲಿ. Fine. So equation which we have got is IDS equals to mu into Cox. Cox ಅಂದ್ರೆ ಏನು actually epsilon naught by Tox. Okay. ಇದನ್ನು ನೋಡಿವಿ ಮುಂಚೆ. W by L VGS minus VT minus VDS by 2 into VDS. VDS is that VDS is outside. Okay. And epsilon naught by Tox ಏನು ಬರ್ತೀನಿ ನಾವು? Let me write it now. ಇದನ್ನು ನೋಡಿ ಅದನ್ನು ಬರೆಯೋಣ. So IDS is equals to mu into epsilon naught by Tox and let Cox. Okay. W by L into VGS minus VT minus VDS by 2 into VDS. This is the equation. W by L equal to epsilon naught by Tox ಅಂದ್ರೆ Cox mu ಐತಿ ಇಲ್ಲಿ. VGC ಅಂದ್ರೆ VGS minus VDS by 2 minus VT ಐತಿ minus VT last VDS ಐತಿ VDS. This is the equation of current, okay, in linear region of operation. This is the equation of current in linear region of operation. E current ಏನು ಹೇಳ್ತದಂದ್ರೆ current which is flowing in linear region of operation. That equation is this. What is the current? What is the current in cutoff region of operation? Answer one plus correct is yes sir. Cutoff region zero. ಯಾಕಂದ್ರೆ MOSFET on ಇಲ್ಲ ಅಲ್ಲಿ. So this is linear region. This is cutoff region. One more is saturation region. Okay. So saturation region ಯಾವಾಗ ಬರ್ತದ ಅಂತಂದ್ರೆ saturation region ಯಾವಾಗ ಬರ್ತದ ಅಂತಂದ್ರೆ ಈ ಗ್ರಾಫ್ ನೋಡಿದ್ರಲ್ಲ ನಾವು ಹಿಂಗ್ ಬಂದು ಹಿಂಗ್ ಬರ್ತದ ಈ ಗ್ರಾಫ್ ಒಳಗ this is what VP ಇದೇನೈತಿ this is IDS this is VDS ಹೌದು VDS ಜಾಸ್ತಿ ಮಾಡತ್ತೀನಿ ಕರೆಂಟ್ ಜಾಸ್ತಿ ಆಗಿರ್ತದ after pinch of voltage the current will saturate. So this VP or the pinch of voltage or the voltage at which pinch off occurs is defined by so ಯಾವಾಗ ಆಗ್ತದ ಅದು ಯಾವ ವೋಲ್ಟೇಜ್ ಗೆ ಆಗ್ತದ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಅಂದ್ರೆ VGS minus VT ಗೆ ಆಗ್ತದ ಅದು VGS minus VT ಈ ವೋಲ್ಟೇಜ್ ಗೆ ಪಿಂಚ್ ಆಫ್ ಆಗ್ತದೆ VGS minus VT when VDS is equals to VGS minus VT at that time pinch off will happen. ಇನ್ನೊಮ್ಮೆ ಹೇಳ್ತೀನಿ ಇನಿಷಿಯಲಿ ಇದು VDS ಇದೆ ಗ್ರಾಫ್ ನೋಡಿ ಇದು VDS ಇನಿಷಿಯಲಿ VDS 0 ಐತಿ ಜಾಸ್ತಿ ಮಾಡ್ತೀರಿ 1 2 3 ಜಾಸ್ತಿ ಮಾಡ್ಲಿಕ್ಕತ್ತೀರಿ ಕಂಟಿನ್ಯೂ ಒಂದು ಪಾಯಿಂಟ್ ಆಫ್ ಟೈಮ್ ಏನಾಗ್ತದೆ ಅಂದ್ರೆ VDS ಜಾಸ್ತಿ ಮಾಡ್ಕೊಂಡು ಈ ವೋಲ್ಟೇಜಿಗೆ ಈಕ್ವಲ್ ಆಗ್ತದೆ. ಈ ವೋಲ್ಟೇಜ್ ಅಂದ್ರೆ ಯಾವ ವೋಲ್ಟೇಜ್ VGS which we have given ಮ್ಯಾಲ್ ಕೊಟ್ಟಿರ್ತೀವಲ್ಲ ನಾವು ಇಲ್ಲಿ ಇದೇ VGS ಸೇ ಇದನ್ನ 6 ವೋಲ್ಟ್ ಕೊಡ್ತೀನಿ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ 6 ವೋಲ್ಟ್ಸ್ ಮೈನಸ್ VT ಅಂದ್ರೆ 0.7 6 minus 0.7 5.3 ವೋಲ್ಟೇಜ್ ಇದು 0 1 2 3 ಜಾಸ್ತಿ ಮಾಡತ್ತೀನಿ VDS ನಾಗ ಎಲ್ಲಿ 5.3 ಬಂತಲ್ಲ ಅಲ್ಲಿ ಸ್ಯಾಚುರೇಷನ್ ಆಗ್ತದೆ. So when VDS equals to VGS minus VT, at that point saturation happens. So ನಮ್ಗೆ saturation region ದಾಗ ಕರೆಂಟ್ ಬೇಕಂದ್ರೆ ನಾವು ಏನು ಮಾಡಬೇಕು ಈ ಇಕ್ವೇಷನ್ ಒಳಗೆ ಎಲ್ಲಿ VGS minus VT ಐತಿ or ಎಲ್ಲಿ VDS ಐತಿ that VDS should be replaced by VGS minus VT. ಯಾಕಂದ್ರೆ ಎರಡು ಸೇಮ್ ಅದ ಸ್ಯಾಚುರೇಷನ್ ಪಾಯಿಂಟಿಗೆ ಎರಡು ಸೇಮ್ ಇರ್ತದ. ಸೊ VDS ಎಲ್ಲಿ ಐತಲ್ಲ ಆ VDS ನ VGS minus VT ಗಿಂತ ರಿಪ್ಲೇಸ್ ಮಾಡಬೇಕು. Replacing VDS by VGS minus VT ಯಾಕಂದ್ರೆ ಎರಡು ಸೇಮ್ ಇರ್ತದ at saturation. Therefore, U into C of W by L into VGS minus VT, okay, minus VGS minus VT substitute ಮಾಡಿ next ಇನ್ನೊಂದು ಕಡೆ ಏನು ಮಾಡ್ರಿ ಮುಂದೆ ಅಲ್ಲೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ VGS minus VT divided by 2, okay, into VGS minus VT. ಇದನ್ನು ಸಾಲ್ವ್ ಮಾಡ್ರಿ. ಇದನ್ನು ಸಾಲ್ವ್ ಮಾಡ್ರಿ ಎಷ್ಟು ಬರ್ತದ ಇಲ್ಲಿ ಡಿವೈಡೆಡ್ ಬೈ 2 ಐತಿ ಹೌದಾ ಹೋಲ್ ಡಿವೈಡೆಡ್ ಬೈ 2 ಮಾಡಿದ್ರೆ ಏನು ಮಾಡ್ತೀವಿ ಇಂಟು 2 ಮಾಡ್ತೀವಿ ಅಥವಾ what ಸಾಲ್ವ್ ಮಾಡ್ರಿ ಹೇಗೆ ಮಾಡಿ ಇದನ್ನು ಸಾಲ್ವ್ ಮಾಡ್ರಿ VGS minus VT the whole square. क्या करना है? Confusion anything ordering. Either what you have to think here, VGS minus VT minus VGS minus VT by 2. Andre, this is like 1 apple minus half apple. VGS minus VT is 1 apple minus VGS minus VT by 2 is half apple. So half apple only. ಇಲ್ಲಿ ಹೊರಗೆ ಒಂದು ಆಪಲ್ ಇದೆ. ಸೊ 2 ಹೊರಗೆ ತೆಗೆದು ಬಿಡ್ರಿ, 2 ಈ ಕಡೆ ಹೊರಗೆ ತೆಗೆದು ಬಿಡ್ರಿ. VGS minus VT into VGS minus VT square ಈ 2 ಹೊರಗೆ ಬಂದಿದೆ. ಓಕೆ, and for simplicity ಈಸಿ ಆಗಿ ಅಂತ ಏನು ಮಾಡ್ತಾರ, ಈ ಪೂರಾ ಟರ್ಮ್ ಇಲ್ಲ, ಈ ಪೂರಾ ಟರ್ಮ್ ಈಗ they will call it as beta. Beta ಅಂದ್ರೆ ಏನು ಕೇಳಿದ್ರೆ ಇದೆ ಪೂರಾ beta. mu into C of W by L is beta. So the equation is ಈ beta ಬರ್ತದಲ್ಲ, this is the expression. These are the 3 expressions. ಇದಂತೂ ಗೊತ್ತೈತಿ, ಕಟ್ ಆಫ್ ರೀಜನ್ ಕರೆಂಟೇ ಇರಂಗಿಲ್ಲ, ಡಿವೈಸ್ ಆಫ್ beta by 2 VGS minus VT the whole square, beta by 2 VGS minus VT the whole square in saturation region, and beta into VGS minus VT minus VDS by 2 into VDS for linear region. These are the 3 equations of MOSFET in 3 different regions. In cutoff region the current hinge irtiti, saturation region the current hinge irtiti, linear region the current hinge irtiti.